Hi everybody, in this video we are going to talk about the volume of pyramids and cones. So a pyramid is different from a prism in that a prism would have two bases and they're both the same, they're congruent and parallel to each other. A pyramid would only have one base and then it just comes to a point at the top. And whereas the sides of a prism are parallelograms, the sides of a pyramid would all be triangles, even if the base is not a triangle. And a cone is very similar to a pyramid. It's got a base, it comes to a point at the top called the apex. The top of all of these would be called the apex of the object. The only difference is that the side of a cone is curved. The surface around it is curved, so it's not triangles. But the principle behind finding the volume of a cone is the same as that for finding the volume of a pyramid. This one would be called a triangular pyramid because the base is a triangle. This would be called a square pyramid because the base is a square. I don't know. That kind of looks like doesn't look like a square to me. Maybe a rectangular pyramid is a better name for that one. But anyway, and then this would be a hexagonal pyramid because the base is a hexagon. You get the idea. So it's named after the shape of the base, but for it to be a pyramid, it's got to come to a point at the top called the apex, and all of the sides have to be triangles. Okay, you can see all the sides around here are triangles. So let's figure out how to find the volume of a pyramid and a cone. So imagine pouring water into a cylinder and a cone. We'll use an example of a cylinder and a cone, but the idea is the same for any kind of pyramid. Both with the same radius and height. So the radius of this cylinder is the same length as the radius of the cone, and the height of the cylinder is the same as the height of the cone. All right? Which container do you think would hold more water, and how many times more water do you think it would hold? So just pause the video for a little while and think about that. Which one of these, if you were to pour water into it, would hold more water? And how many times more water? Two times more water, so twice as much. 3 times as much water. 3.5 times. 4 times. 4.1 times. What do you think? All right, the answer is that the cylinder would hold more water. And in fact, it would hold exactly 3 times as much more water as a cone that had the same radius and the same height. Okay, 3 times as much for the cylinder. I'm not going to prove that in this video. You're just going to have to take my word for it. Maybe in high school, you'll see the proof of that. But if you want to do an experiment at home and you're kind of a neat person and you're the adults in the house or the apartment let you do this, you could try taking a cylinder and a cone and actually make sure that the bases are the same and the heights are the same and pour water into it. And you would see that if you pour water into the cone and then dump it into the cylinder and then pour water into the cone again and then dump it into the cylinder, you would have to do that 3 times in order to fill the cylinder up. All right, so let's move on here. So a cylinder has exactly 3 times as much volume as a cone with the same radius and height. If the volume of a cylinder with a radius r and a height h is pi r squared times h. So we saw that in the other video. If I have a cylinder over here and the radius is r and the height is h, then the volume of that cylinder would be the area of the base times the height. The area of the base is pi r squared, and then we would multiply that by the height. So this expression over here is the volume of the cylinder. So if we know that this is how to figure out the volume of the cylinder, and we also know that the cylinder is 3 times as large as the cone, then what do you think the volume of a cone By the way, when I say 3 times as large, I mean the volume is 3 times as much. Okay, not that the height is 3 times as much. The height is the same, radius is the same, but you could fit 3 times as many cubic units into the cylinder as the cone. All right, so if this is the volume of the cylinder, then what would the volume of the cone be? Pause the video, think about it. The answer is that it would be pi r squared times h divided by 3. So if I know what the volume of the cylinder is, I would have to divide that by 3 in order to figure out the volume of the cone, because the volume of the cone is only 1/3 as much as the volume of the cylinder. Okay? All right. So remember, this is sort of a review of what we saw in the last video and what we just talked about here. The volume of a prism is just base times height. So you have to remember what the area of the base is, and then you have to look at the shape of the base, and then remember how to figure out the area of that shape, and then multiply it by the height in order to figure out the volume. But we know that a cone and a pyramid, would only have 1/3 as much volume as a cylinder or a prism with the same base. Okay, so we would have, in order to figure out the volume formulas for the pyramids, we would have to just take the volume formula for the prism that has the same base and then divide it by 3. Okay, we already did that for the cone over here. So the volume of a cylinder is pi r squared times h. The volume of a cone would be pi r squared times h divided by 3. Now let's do that for a rectangular pyramid and also a triangular pyramid. So if the volume of a rectangular prism is length times width times height, then the volume of a rectangular pyramid would be length times width times height divided by 3. So you got your base, which is length times width. You got your height, which is h over here, and then you divide it by 3. Okay, so simple enough. What would the formula for the volume of a triangular pyramid be? We would just take the formula for the volume of a triangular prism and divide it by 3. So we have L times P times H divided by 2. I have the H written here in this picture. I'm just going to put that in the numerator right now. And then we would have to divide all of that by 3. So that looks kind of messy. Let's see if we can simplify that a little bit. Whenever we divide something by 2 and then by 3, that's the same thing as dividing by 6. So for example, if I take the number 60 and then I divide it by 2, I would get 30. And then if I take 30 and I divide it by 3, I would get 6. What did I just say? You did not hear that. I lost my train of thought. If I take 30 and divide it by 3, I would get 10. Okay. All right. So if I divide by 2 and then divide by 3, that's what I get. I would get the same answer if I took 60 and instead of dividing it by 2 and then by 3, I just divided it by 6. 60 divided by 6 is also 10. I think that's why I said 6 before, as I was thinking of what I was about to do. Okay, but dividing something by 2 and then by 3 is the same thing as dividing it by 6. So we can just write this as L times P times H divided by 6. Okay, but don't get confused with that 6. It is still the volume of the prism divided by 3. It's just that there was a 2 over here in the formula for the volume of the prism. So when we divide by 2 and then divide by 3, it's like dividing by 6. All right, so let's go ahead and do a couple problems. This is from Glencoe. A funnel is used to fill the transmission of a car. Find the volume of the funnel. So this funnel is in the shape of a cone. So the volume formula would be pi r squared times h divided by 3. And we're just going to use 3.14 for pi. So we have v is equal to 3.14 times the radius squared. So the radius is 2. We're going to square that and multiply by the height, which is 9, and then divide by 3. Okay, so there are a couple of different ways that we could solve this. It's pretty simple just to simplify this part of it. Let me write this 3.14, and then 2 squared means 2 times 2. 2 times itself. Any number squared means we're multiplying it by itself. So 2 squared means 2 times 2. That would be 4. Times 9 would be 36, and then divided by 3 would be 12. So this whole thing is like 3.14 times 12. And then we could just work that out. Whoops. So 3.14 times 12, 37.68. So that's going to be our answer for this problem. Okay, and that would be cubic inches. So IN and then raised to the third power. We need an exponent of 3 there. Let's do the next problem. Another Glencoe word problem. The attic of a house is shaped like a rectangular pyramid as shown. If the volume of the attic is 4,376 cubic feet, what is its height? Okay, so in this problem, we're told what the volume is. We have to figure out what the height is. Let's first go ahead and write the formula for the volume of a rectangular pyramid, which is, you know what, if you don't want to memorize the formulas, I don't memorize the formulas either, to be honest with you. I just know that for a pyramid, it's going to be base times height divided by 3. I know that the base is a rectangle, so to find the area of a rectangle, I do length times width. Then we're going to multiply by the height and then divide by 3. So there's our formula. You don't have to memorize it if you understand what you're doing. And then let's just plug in what we know and solve for what we're looking for. So we know that the volume is 4,375 cubic feet. Let's plug that number in for V here. The length is 35. The width is 25. You could also call this the width and this the length. It doesn't really matter. Okay, so 35 times 25, and then times the height, which is what we're looking for, so we'll just put an H there, divided by 3. So there are a couple of different ways of solving this equation here for H. What we could do is multiply 35 by 25. And I am just going to use a simple calculator for that. So 35 times 25 is 875. So we have 4,375 equals 875 times h divided by 3. And we can multiply both sides by 3 to cancel this 3 in the denominator here. And we would get 875h is equal to, let's see, so we want to do 4,375 times 3. We get 13,125. Okay, then let's divide both sides by 875. I always seem to run out of space right at this point, like every time. So I'm going to get h equals 15. Okay, so we just learned that the height of this pyramid is 15 feet. Okay, height is just one-dimensional, so that would just be feet, not square feet or cubic feet. All right, so that's it. I'm going to end the video there, and have a great day.